All right, in this question, we're given the molar solubility right here, and we're trying to determine the KSP. So we're gonna have to set up our KSP expression, our equilibrium expression. But the nice thing with this one is it writes it out for us. So it gives us our solid and then what it breaks into. Notice this 2 out here, this is gonna play a role in solving for the KSP, both in how much the concentration is, and also our expression will have a square in it. So that's really important to remember. So first thing we need to do is realize that this will not be part of our ice table, even though sometimes in class I'll write like a -s here. In the official ice table, it's not included because it is a solid. So I'm going to bring up these. Now, we start with 0 of both of these, and then we are actually given the value. Now, this is plus S, and this is plus 2S, right? But molar solubility is S, so we're actually given this value, and this value will go here, and then 2 times this value will go here. So let's put those in. 2.7 times 10 to the -3. It's positive. And then 2.7 times 10 to the -3 times 2 is 5.4 times 10 to the -3. And so those same values will go here. Now we will use these, so we have to remember these as we go to the next step, to step 2, because they will go into our expression. Now, we have 2.7 times 10 to the -3. There's nothing on the bottom because we have a solid on the bottom. But here's the tricky part. We need 5.4 times 10 to the -3 squared because it is a 2-to-1 ratio. So that 2 coefficient comes into play 2 places. First, in doubling this concentration, and second, in the square of that concentration. So let's do this in our calculator. We're going to do 5.4 EE minus 3. We're going to square that. Then we will multiply that by 2.7 EE minus 3. And we get 7.87 times 10 to the -8. 7.9. There we go. So the biggest thing with these is that coefficient and recognizing that we were given S, which then had to be modified in this IO3 minus because there's a 2-to-1 ratio.